Hello, I hope you're all having a great day or evening. My name is Caleb Brown, and I am one of the two team members behind Pulse, the other being my partner, Ayush Naidu. I am a freshman undergraduate physics major at Texas A&M, and I'm very excited to present to you our device, the wave generator. So, to get started with the purpose and motivation behind our device, I remember it being somewhat of a personal one. I was sitting in my introduction to quantum class at the very beginning of the semester when we first started talking about wave packets, which are essentially packets of energy that are carried by light. And I remember thinking when I was looking at this that if you swap the words energy and information, you all of a sudden have a packet of information that can describe so many physical phenomena. If you had, for instance, sound instead of light, then an increase of energy, which would be normally associated with an increase in energy in a light wave packet, would be similar to an increase in the pitch of a note being played on an instrument in a little sound wave packet. This led me to continue to think about this, and I realized that for how difficult of a concept waves are, they are all around us, and their beauty is something that should be understood. So I want to show that beauty to those who might struggle with understanding it on an on a rigorous academic level. Along with that, I want to engage students with ideas that are associated with science, art, and engineering. When you think about it, they are all related in a very beautiful way, and I think our device can show that. However, in order to take these ideas further, there does need to be some sort of introduction to the mathematical and physical principles behind standing waves, which is what these next two slides will cover. There are multiple examples of where standing waves show up and how you can use each situation to describe what a standing wave is. But I think the best way to demonstrate how a standing wave works is by using this scenario that every child eventually finds themselves in. So imagine you're at a playground and you see two children playing with a jump rope. Each child has one end of the jump rope, and children being children, they shake the jump rope about, and it's just complete chaos. The jump rope is just flailing, and there's nothing noticeable really happening. However, after 2 minutes, you notice that they start shaking the rope in a rhythmic pattern, and this little half wave starts to form, similar to the image in the bottom right. Interesting. But they eventually start to shake it even faster with the same rhythm, and two waves start to form. And then they go even faster than 3, and then 4, and then 5, and so on and so forth. Up to infinity, really, if they could shake it that fast. But it's this idea right here that our device is trying to encapsulate and replicate to its users. So in order to bring this to life, there are a few formulas that we had to follow. The three most important ones are shown right here, which is lambda n being any sort of given harmonic. N is also the number of standing waves, but those standing waves correlate with the harmonic. Lambda n being twice the length over the number of standing waves. The frequency n being equal to the velocity of the string over lambda n. And then this function y of x being the shape of the wave at a given displacement. The third one here in particular is very important because it's what we needed to overcome a design challenge that we eventually came up, and that is the visibility of the string as it was being oscillated. The other two formulas is what we're trying to show to our users. So with our tools in hand, we started sketching and making models. And here on our left, you will see our initial prototype idea that never got made. It was way too technical and too difficult. We essentially had two towers. The towers would be adjustable in length, and we would have two rollers going up and down, creating these waves instead of just one point that oscillates the wave and reflects it back and forth. This proved to be way too difficult, and we wanted to have as much simplicity with the Arduino kit as possible. So we eventually borrowed inspiration from Da Vinci and his flying machine and created this crankshaft mechanism, as you can see in the top right picture. And what will happen is we give power to this crankshaft, and it essentially creates an up and down motion on a pin that causes a wave to form along the string. And we went and ran with this the whole way through. So with committing that design, here we have a list of challenges and solutions that we have faced. Of these, the most pressing, I would say, is showing the standing wave itself traveling before it's actually even formed. This is going to be incredibly difficult to perform. I think we can possibly do it, but we would need a very long string in order to show that. But as the string length increases, we would need a higher frequency to show more waves forming. And that is just gonna be very difficult. We have fixed this by increasing the length of the string, but also allowing the length of the towers to be adjustable. So at any time we can just move the towers and then increase the frequency to show that. Another difficult one that we've came across is showing the standing wave being fully, I guess, appeared. We decided to place a dark background behind it to fix that one. Image is the final design. On the left, you can see the adjustable length of the device being shown by the big long pieces connecting with each other. We simply remove that and then make the line, the string, shorter by pulling. There's a mass behind it you can't see, but pulling the mass down further. And then for the breadboard, we did have to put a limiter on it to not push it beyond its.
네, 정해진 시간이 다 돼서 여기서 잠깐 멈추겠습니다. 혹시 시연 영상 같은 것이 있으면 좀 볼 수 있을까요?
네, 잠시만요.
네.
네, 30초 정도 되는 시연 영상인 것 같습니다.
예, 좋습니다. 자, 질문 드리겠습니다. 이 프로젝트는 지금 이제 이 학생들은 미국에 지금 재학 중인 학생들이죠?
네, 맞습니다.
그러면 이 프로젝트는 지금 누구를 대상으로 하면 도움이 된다고 이렇게 생각을 하고 만들었을까요?
처음에는 초등학교 전체 다를 생각을 했었는데 만들다 보니까 저학년들한테는 컨셉이 좀 어려울 수 있다는 생각을 해서 초등학교 고학년 정도는 돼야 되겠다고 생각을 했던 것 같습니다.
네. 포디 프레임으로 제작한 이 피지컬 디자인 쪽을 좀 더 튼튼하게 제작할 수 있는 방법은 없을까요?
좀 더 튼튼하게 제작하려면 포디 프레임 안에 뭐 철사를 넣는다든가 아니면은 그 헤어 드라이기로 좀 이렇게 따뜻하게 했다가 식히면 좀 더 단단해지더라고요. 그런 식으로 하면 좀 더 발전이 할 수 있을 것 같긴 합니다.
지금 이제 다음 질문입니다. 이 웨이브 모습을 보려고 흰색 실을 매단 것 같아요. 그 흰색
네,
실이어서 좀 잘 안 보일 수가 있거든요. 영상이나 이런 거는. 그걸 좀 더 선명하게 보일 수 있는 방법은 없을까요?
네, 아까 전에 이 발표하던 친구가 말을 했는데 실제 시연 영상에는 그렇게 안 했네요. 발표할 때는 사실 뒤에 백그라운드에 검은색을 대겠다고 했었거든요. 시연 영상에는 보니까는 안 되고 이렇게 영상을 찍은 것 같아요.
예, 알겠습니다. 발표 잘 봤습니다.